Hey guys, as usual, welcome back to day 15 of LeetCode problem solving. And today's question number is 160. And like always, we are trying to solve a question related to DSA. And like yesterday, we are trying to solve a question related to linked list. Let's look at the topic of the question. The topic is two pointer linked list and hash table. Let's read the description of the question. Given the head of two singly, okay, so it's a normal linked list, head A and head B, return the node at which the two in list intersects. If the two link list have no intersection at all, return null. For example, the following two linked lists begin to intersect at C1. The test case are generated such that there are no cycle anywhere in the entire link structure. Note that the linked list must retain their original structure after the function return custom jaws. Okay, so it is mentioned in the value given for each linked list. The jaws will then create the link. Okay, okay. So it is like usual. These are the value which is given to the computer, and it will create the linked list according to this value, and we are only given the head A and head B, which is the pointer pointing towards the head node of linked list A and linked list B. Okay, so intersection value is given 8 here, so it will intersect at 8. It means that they will use same memory block to store node, or they will share same common node. Okay, so there is zero possibility of the linked list being a cycle linked list, as it is clearly mentioned here that the linked list is singly, which means it is a normal type of linked list. So I think uh, what we could do is mm, uh, if we so if we go from here, as you can see, is if we try to run the loop from this starting of the okay, so it is not doubly linked list, so we can't use previous next values. So what we have to do is have to use two pointer as given here. One pointer will move one block forward, whereas another pointer will move two block forward. So I think what we can do is uh, let's suppose this is the first linked list. Let's take the linked list given here as the example 41845. 41845 and 5. Okay, so there are five nodes, 3, 4, and 5. 4, 1, 8, 4, and 5. Okay, and the second link list has 561 845. 561 845. 561 845. So let's make the node 561. Then the block are same. So this is pointing here, and this is pointing here, this is pointing here, and this is pointing here. And the last node is pointing towards null, and this is pointing here, this is pointing here, and this is pointing here. So as the question consists of double pointer as topic, and yesterday we solved the question of double pointer using fast and slow pointer. So what I think we should do is we should make a four pointer named slow A, fast A, and slow B, and also fast B. And what we can do is we can uh, check the address of each pointer. Like we can check slow A with slow B, and slow A with fast B, and fast A with slow B, and fast A with fast B. If any of the address match, then uh, that address will be the point where the intersection occur. Whereas if uh, any of the address leads to null, then we should return null. What I'm trying to say is, let's suppose slow A is pointing here, fast A is pointing here. This is slow A, this is fast A, this is slow B, and not beta, it's slow B, and this is fast B. What we can do is, let's erase this first. Okay, so we'll compare the next address uh, pointed by each of this. Okay, instead of using next, I think it's better to use the address of this pointer is the intersection can also occur in the first node. So what we can do is we can compare the we can use a if block mentioning if as say, or the slow node A is equals to slow node B, or slow node A equals to fast B, or fast A equals to slow B, or fast A equals to fast B. If any of the condition is true, then that address should be written. But okay, so we won't know which address to return unless we use each of these condition in individual block. Okay, so that should be done. And as you can see, the address of 4 is not equals to address of or any of these addresses are not equal. So fast will move by 2 block and it will come here. Slow will move by a single block and it will come here. Uh, Slow will move 1 block and it will come here, and fast will move 1 block and it will come here. Okay, so now fast is pointing here, fast A is pointing here, slow A is pointing here, slow B is pointing here, uh, and fast B is pointing here. As none of the address are same, so it will move by a single block again. And now slow A will be at 8, fast A will be at, it will be at null. Okay, so this won't work as it has already gone to null and we don't have our desired address. Mm, Size of the node dot value and command, it can be up to 30,000, and it can be given in this way, right? There are 30,000 block here and the last value is 2 and 3, and we can simply have a node with 3 block which start with 1 and it can have 2 and 3. If it occurs like this, then it will have to traverse all the way and it will have to come here, whereas the second linked list will only have 3 value. If the linked list were equal, then the problem would have been a lot easier. But sorry, as you can see, that's not the case here. So we can't use that method as it is stealing to use two pointer. So using two pointer like this also doesn't work. As suppose if there were equal block and uh, it what I'm trying to say is if there was equal block, suppose there was not one here, then the fast block would have this, yeah, right? Is both fast A and fast B were pointing in 4, so the program would have returned 4. However, as you can see, our intersect section node is 8, not 4. So even though the number of nodes are equal, the solution will always be false in such case as first node is always traversing two block, and if it is traversing by two block, then it means that uh, if the intersection block lies in odd place, then as we know, first block is traveling in even number, so that won't work. But what happens if first is also pointing in first block? Okay, let's see that. Okay, let's erase this and all this and this too and this too. Okay, so if fast were also to be pointing in same block, then in such case there will be one right. Uh, in such case, slow is traversing one block, fast is traversing two block. Slow is traversing one block, fast is traversing. Okay, sorry, my bad. If fastest traversing two block, then it will end up at 8. Now we can see this is at 8 and this is fast is at 1. So none of the address match. And again, now fast will come at, yeah, and fast will come, okay, that won't happen as 8 is the point where the intersection occurs. So fast will come here. So not the same block, uh, but slow will move by one block. This slow is also moved by one block. And in next iteration, fast, we can simply terminate fast uh, node as it is already null. And fast we also can be terminated as it also returns to null. So now slow move by one block, slow also move by one block. Yeah, that won't work as uh, it already skipped one block, right? Oh. So what we do? Fast and slow also didn't work. Mm, so we have to think of a new way to solve the problem. Okay, let's see. As we have to compare address, we could compare each address present here with each address present here, right? That can be done. What you can do is you can use slow and fast here too. And what you can do is so we can compare slow node with all the node present here and fast node with all the node present here, right? And this node too. And after that, slow will move by one block, whereas fast will move by two blocks. Then we can again compare with each block and fast with each block. As we can see, the fast here, sorry, the fast node is pointing at 8, and the fast will compare each value present here. The value will be equal. So we can return the value. What do we have to return? We have to return value, right? Yeah. We have to return the value, or yeah, we have to return the value. What we have to do now is uh, we have we have to create two temp uh, list node temp a equals to add a and least node temp b equals to add b semicolon. After that, while okay, we need slow A and fast A, not temp A. Not slow node. Least node A equals not A, fast A. Fast A equals to A. Uh, should we use slow B and fast B this time too? Is we will be able to cover each iteration, right? Uh, so if we are using A fast A, slow B fast B, then what will happen is while using slow A will compare this with this and this, and fast A will uh, compare with uh, this with this and this. Yeah, we are comparing two different nodes at the same time. That should work. Okay, so what we have to do is we have to add next year. Before doing that, what we should do is we need if condition if add A equals to null or add B equals to null. In such case, we will return null. Such case, we will return null. And if both of them are not, then what next condition we should implement is if uh, okay, what will happen if there is a single node and we are using a node for pointing to both node, right? Not like this. If there is single node and both aid are pointing towards first node, then the answer will be true. Okay, so in that condition, what we can compare is if aid A equals to aid B, then return aid A 1. Yeah. And next condition what we have to compare is if A next equals to null pointer or add B next equals to uh, null pointer. Okay, we can do this condition after we have assigned the value is if add A or add B are not null, then we can use add A next and add B next. So it should be fine. So we can use slow B here and this node fast B here add B next. Now we need a while condition. While slow A. Okay, so before doing that, I think it is good to compare whether the address present inside of them are equal or not. If slow A equals to slow B or slow A equals to fast B or uh, fast A equals to slow B, or so these are each individual conditions, so it's better to get. So I'm trying to check whether this equals to this, not that. I'm trying to check. Let's erase all this first. What I'm trying to check is I'm trying to compare this with this and this with this. If any of them are true, then it should be equal, right? So we can use it inside of while block. So what should be the algorithm? While, but okay, let's do this then. While slow A is not equals to null and fast A is not equals to null and slow B is not equals to null and fast B is not equals to null. I think I should only use uh, I think I should only use slow B, right? As if we have two pointer here, then it will be hard to each time move to block forward. So okay, I will only use team B and not fast B and slow B. Team B. Okay, so instead of doing all this, what I can simply do is I can team B. Sorry. So now we can return false if any of these are null. Else, we can compare if slow A is equals to temp uh, temp B, then we will return the value present inside of either of them, which is fine. If they share same memory block and the value is yeah, it is defined as val. In another condition, what we can compare is else if slow not slow fast A equals to temp B. If this is equal, then we will return uh, fast A val, and if neither of them are equal, what we are doing is uh, sorry, we are using slow and fast A, and we are comparing this with the first memory block, right? And in next iteration, slow will move here, fast will move here, and we'll compare this with this. Next step, we'll compare this with two. It will be null. Okay, so let's see. If it is null, then what will happen? If this is null, then we'll simply exit the loop and return false. But the desired answer is not false. Okay, so this is not working either. We have to compare this to with this. In next step, we will compare Uh, uh, this two with this. Next step will compare this with mm, compare this with as it is already null. Yeah, no, no. It went here, then it went here. Yeah, we'll compare this with this. Next step, we'll compare this with this. It's already null, and next step, we'll compare this with this. Next step, it will be null, and it will be and the answer will be false. So, uh, if they are odd, then and as there is no cycle, so the concept of it will eventually come back to the same position doesn't work. Yeah. So what should we do? We need to compare the address. The first thing what I thought was uh, we could uh, simply traverse to the we could simply find the null and we could traverse backward, but it's not doubly linked. This so traversing in backward direction is not possible. If we could traverse in backward direction, what we could have done is we can simply we could have simply gone to the last node in each last node in each block, and after going there, if last node is not equal of both if last node of both linked list is not equal, then it simply doesn't intersect anywhere, and the answer would have been false. And if they were equal, then we could simply backtrack and come each block ahead, and we could come each block ahead uh, until the address become different. After the address become different, we can simply return the previous value, as we know that uh, the last block where the address was same was the first block where the intersection was there. So as it is not a doubly linked list, so the solution is not feasible here. The question simply states we need to use two pointers. So two pointers should be used, but I don't know in which way. Today I had work, so I couldn't study two pointer as I told yesterday I will study. So I don't know the method in which we can use two pointer. Uh, I don't think I have any other kind of solution for solving the problem. Is all the idea I'm thinking right now doesn't work. Let's see. So one, if the number of node were to be equal, then it would have been a lot easier. But as the number of node is not equal, so the problem is proving to be a bit difficult. Let's look at another question, and we can solve this question tomorrow after learning about double linked list. Sorry, not double linked list, double pointer. What is the title? Title is remove linked list element. Given the of a linked list, and then integer val, remove all the node of the linked list that as node dot val equals to val and return the new head. Okay, we can do that. We can do this today, and we will try to solve this tomorrow. Okay. So as I wasn't able to learn about two pointer today, so I will simply leave this question here for today, and I promise I won't look at the solution, and I will try to solve it tomorrow by simply learning about the concept of two pointer, and I will also look at SMAP, as I have seen a lot of the question I am solving as alternative solution using SMAP. I think SMAP is very important. I know what's a SMAP. Sorry, SMAP is SMAP. I think uh, from what I know, SMAP simply refers to the data structure like uh, object in JavaScript, right? We have uh, uh, just like in JavaScript, sorry, just like in JavaScript, we declare a object like this, right? Is let's suppose x equals to 4, y equals to 5, and z equals to 6, and we do this and we simply close it. Yeah. So it has a key and it has a value and it always comes in a pair. That's swap, right? I'll try to see what as table is. I think as table is a bit different than swap. I don't actually know about it. I'll try to solve it tomorrow. What today we'll solve this. We will solve this remove linked list. What's the topic? It's simply linked list and recursion. So the question is simply telling us it will give us a head node in or a pointer pointing towards the first node in the value. And what we have to do is delete all the value from the linked list which value is same as the value given value and return the head node. So the value present inside of head node shouldn't be altered. So we need to create a temporary pointer pointing towards head. After that, what we can do is we can simply use while loop and we say while temp uh, while temp is not equals to null. What why we are so what I'm trying to do is suppose let's look at the example 1 2 6 3 4 5 6 1 2 6 3 4 5 and 6. I'm not using a digitizer, I'm using mouse, so it's a bit difficult to draw. 1 2 6 3 4 5 and 6. So this is our linked list. It is a single linked list or the default linked list. And each time we'll traverse each block, checking whether the block is null or not. And each time we'll compare the value. Is here we can see in the third node as the value given to us, right? Yeah, the given value is 6. So we will remove this node, and in order to remove this node, we require a algorithm. As we need after removing this node, the pointer present inside of the node whose value is 2 should point towards the node whose value is 3. Okay, so what we need to do is uh, instead of comparing the value of present node, we need to compare the value of next node. Is we aren't using a doubly linked list, so we can't backtrack. So when our pointer is pointing towards 1, we need to compare the value present inside of second block in second iteration, or in when our pointer is pointing towards second block, we need to compare the value present inside of first, sorry, third block. So the first in the foremost condition should always be if head is equals to null, and if head is null, then simply return head without doing anything. Whereas uh, uh, if head is not null, then what we have to compare is if let's see if head uh, val equals to the given val or value if value present inside of we can all put this over here. It will help to save us a bit of memory. uh, Head value equals to the value, then we can simply uh, what we can do is we can simply delete it. After deleting it, we can use add to point towards null, and we can simply return it as if the value okay is uh, and add add next equals to add next equals to null. If add is the only block present and the value present inside of add is the given value, then we can simply delete the add or the memory block pointed by add, and we can assign add to null and we can return add. In other condition, we need to check if temp next is not equals to null. As in each step, we are comparing next value. And if the next is null, then it simply means that let's say we are right, and if it is pointing towards null, if it is pointing towards null, then it means there is no value here. So we can't access this block, or we don't have any value here. So what we can do is, if temp next is not equals to null pointer, then while temp next is not equals to null pointer, then we can compare temp next value equals to value. As we have already compared the value present inside a first block, so we can compare now of second block in other block on void of the air block. Uh, if temp next value equals to value, then what we have to do is let's erase this and I will try to visualize it. Let's say, let's say we are at uh, uh, our temp is pointing at 2, right? And as we know, when our temp is pointing towards 2, we are checking the value present inside of third block, which is 6. So as the value is equal, so this if condition is true, and the control of the program came here, right? So now we have to delete this. So before deleting this block, what we need to do is our temp is here. So we need to assign temp next equals to temp next right? So now our temp next, which is the pointer present inside of here, will point towards this block. So now we can simply erase this block, which we will do. Okay, so so I need another. mm, I didn't consider about another condition like let's say we are in this first block, and if we have other block too like this, and so let's say the given value was 1, right? So we'll compare with this value, and uh, this value is to be deleted, so we'll delete this value, and we need to now point it towards this value, but we aren't considering about this condition. So let's call this let let's call this part. If value is equal, no matter next is null or not, before deleting the block, what we have to do is let's create another block named to delete, and what we can do is list node to delete equals to null. At first, it is pointing towards null, right? So we know the node which is to be deleted, or the address of the node which is to be deleted is present inside of it. So what we can do is we can simply assign to add to delete pointer, and after that, as we know, now we need a condition if add next equals to null. If add next equals to null, then We can simply assign add to null pointer. If add next equals to null, then after deleting the current node, there won't be any node to point. So add should be pointing towards null. And also, we need to delete the node, which is present inside of delete to delete. Yeah. And we need to, yeah, returning part is done here. And if uh, let's use else condition here. Else condition is for when there are multiple nodes beside it. So in such condition, it should point it now should point towards it next, right? And it should now point towards it next, and we can return it now. This condition will only be true when add value equals to or add value is equals to the given value. If the add value is not equals to the given value, then add can simply then add can simply be this uh, then it can be simply this block, and we can compare the block on from the second block. So 10 being 8 doesn't affect is we have already compared the value present inside of 8, and if 8 is deleted, right? Let's say if 8 is deleted, now 8 is pointing here, right? Okay, so mistake will occur as if there are value after 8 and we have deleted 8. So now 8 will point here and it will try to delete the block from here onwards. But as we can see, if 8 node is already deleted, if the 8 node is already deleted, then now it will point here. So we are comparing the value from 6. So this 2 will be left, which is bad. As if this was also 6, this was also 6, then after deleting this add block, we need to delete this 2 too. Uh, so that won't work. What was the topics? Recursion, okay. So we have to call remove elements continuously until the block we want to delete is deleted. Okay. Recursion is required as let's say all the block we have to return all the node present inside of the linked list consist of the node which we have to delete, right? Like this. Then we will call the function, we will delete the head node. Okay, okay, so I got it. What we should do is the value present inside of head is so what we should do is we should uh, call the we should at first the program already called remove elements. So first we need to compare the head node with the given value, right? And if they are equal, then we need to delete the node and check if next pointer is null or not. If it is not null, then we need to again call the function. However, now our head node should be this node, right? And this process will go continuously until all the node with same value are deleted. And if the next is null, if the next is null, then we can simply return the program. Then the program will return sequentially, and it will come here, and will return head here at this part. Uh, that is the only way you can use recursion. Okay. So what I was saying was, uh, let's make our temp uh, let's make our temp pointer pointing towards the head. And now what we need to do is we need to check if head val equals to the val, and if it is equal, then we'll come here, right? And after that, we'll check one condition, which is if add next equals to null. In such case, we can simply assign add to null pointer is simply assigned to add to null pointer. Okay, instead of using add, it is better to use temp as we need to return the value of add. Temp, and this should be temp too. Okay, okay. Temp equals to null pointer. Hmm, and return temp. Will it work or not? If it is null, then return temp. Else in other condition. But if we do this, then hmm, okay, let's see. Okay, okay. I think it will work. Uh, if temp next is not equals to null, then it means we need to use remove elements, remove element, and we need to pass add next each time. So each time add will be add next, and it will be assigned to temp, and temp will be checked if it is uh, and then after this we for the last block we need to return it should be written. Okay, so okay, let's say the program adds register null block, right? So uh, it will come here and it will return temp, which is the aid current aid block. Okay, so it will return temp. So when the program comes here, uh, uh, so when the program comes here, it will have the address of this block, right? And again, uh, as we know, we will be here. It's uh, in other condition, the temp next was not null, so the program will return this. Okay, so instead of this, we need to return 8, which should be the block. It should be the uh, it should be this, and but we should delete the node too, right? I haven't deleted the node, so delete temp and return 8. Should we do that for null that is? And in this case too, we should delete temp and sorry. Okay, so in simple recursion program, what happens is, let's say we are creating a Fibonacci series, then If n equals to if n equals to 1, then return 0. Else if n equals to 2, return 1. Else return uh, calling the same function plus calling the same function n minus 2 by passing this, right? So in other condition, if this condition are met, then it will return this, but however in other condition it will return this, right? So just like that, uh, for the last, for only the last node, this block will be called and it will return 8, which we don't have any use for. So yeah, it is returning 8. Should we assign something here, right? uh, After deleting temp, what if we assign temp to here? So now, uh, after deleting temp, okay, so uh, if the pointer is not null, then we are deleting this, right? We are deleting this, and it will come. What happens if the value is not equal then? Okay, that's a dilemma. The head node should be the node where, okay, I won't use recursion. I will solve it normally. Node temp equals to uh, add, but before that, we need to check if add equals to null pointer, then we should return null pointer, or instead of writing null pointer, just write add. And if temp equals to add, then what we can do is, if temp equals to add, uh, if temp equals to add, sorry, not temp equals to add, now we need a while loop. Before while loop, we need to check the value. If temp val equals to the value, right? Then uh, node to delete equals to null pointer at first. We need to assign to delete to uh, both are fine. Let's use temp, and after that, uh, we need to check if add. Okay, so instead of using if, we can use while. Is if head block is the block which is deleted, then we need to compare next block again, right? What I'm trying to say is, let's say uh, let's say all the block are just like here, uh, one which need to be deleted, right? So at first, the head block will be this, and we will delete this block, and we'll come here. Now head block will be this, and this block should also be deleted. So it's better to use while. Now what we can do is, while temp temp val equals to the given value, right? While temp val equals to the given value, we can assign to delete. We can assign to delete to temp. Now what we can do is, Uh, Now what we can do is we can assign 8 to, sorry, not 8. We can assign temp to temp next, and we can delete to delete. But we need to check another thing. If temp next equals to null, so there was only one memory block, right? So it should be assigned to it should be assigned to null pointer, and we can simply return it, right? However, if head was not null pointer, then temp will be assigned to temp next. Temp will be assigned to temp next, and we will delete to delete. And again, this loop will continue. This loop will continue, and it will check whether the given value is correct value, and if all the value was the value to be deleted, then it will come until all the node are deleted and the next uh, one is null, right? So we'll simply return null as all the node are deleted. However, if the node were present in this format 1, 1, 2, and 3, then first node value is equal. So we'll come here, we will delete the node, and we'll simply temp is simply yeah. So now we'll compare this value again, and this node will also be deleted. Now we are at 2. Now we are at 2. Right. Now we are at 2, whose value is not equals to the given value. So now what we can do is after coming here, we can update it. Now as it all the possible head which should be deleted is already deleted. Now the current temp should be the head. Our permanent head is all the node which are present consecutive to the head which should be deleted is already deleted. Now our current head node is 2, which is not the node which should be deleted. So now we can simply compare the next value. Yeah, that can be done. While temp next is not equals to null, as we are now comparing next value, what we need to do is if temp next value equals to the value, then what we can do is we have to delete. If the given value is the value to be deleted, then we need to do to delete equals to temp next in temp next equals to temp next next. To delete is temp next and temp next, which can be null. Okay, okay. So let's say if this is null, right? So temp is now pointing towards null. Temp next is null, and we are in next condition. We will check. Yeah, we will check temp next equals to null. Okay, to work. Okay, so the node to be deleted is assigned here. Temp is assigned here, and we'll simply do delete to delete. Uh, we simply use continue. Else, if the next value is not equals to the value to be deleted, then what we can do is we can simply temp equals to temp next. Okay, so now we are at 2. Now we are comparing the value present inside of 3, right? We are comparing the value. Is the value is not equal, so we'll come here and we'll move to next block. as the next block is as the next block is simply null, as the next block is simply null, so the while will break and will return add. Whereas if let's say if instead of null being here, there was a value 1 and then null, right? In such case, now as we are pointing 3, so we are comparing the value present inside of 1. The first condition will be temp next not equals to null, as temp next is not null, so we'll compare the value present inside of 1 is temp next value equals to the given value. So to deleted will be the address of this one, and we are assigning temp next, which is the address here. Temp next to temp next, which is temp next, which is null. So null will be assigned in temp next, and now we are deleting this block, and after that we are continue. So current iteration will be skipped and will come here and will compare temp next is not equal to null is temp next is clearly null. So the node to be deleted, all the node to be deleted are deleted, and the while will exit, and now we will return it. And the condition for returning it is also correct, right? If add is null pointer, then simply return add. And if we are using while temp value equals to given value is it is pointing towards first block, right? Yeah, first block, then two deletes should be this block, and after doing that we are checking whether temp next equals to null. Is if the next block was null, then we can simply assign head to head equals to null pointer and return head. uh, we can also delete temp and we are returning, so we will completely exit from this function. And if it is not null in not null, then temp will be assigned to temp next, which is if temp is pointing here, then temp will be assigned here, and the node to be deleted, which is this, will be deleted. And now we are here, and again we are checking if temp value equals to value is temp value is equals to the value. And now another thing we need to check is end temp temp equals to temp next, right? So that yeah, we are already checking if temp next equals to null pointer, so we don't have to worry. I was thinking if temp next was null, then we can't check the value. However, the condition where temp next is null is already countered. So temp equals to temp next, so it moves yeah, and now we will delete the current block, and again we are comparing the value of temp to temp value as the value is same. So will come here, and it will be assigned to delete, and temp will move by next step, and now it will be 2. Now it will be 2. So the node to be deleted, which is 1, is deleted. Now we are at 2. Now we are comparing the value of value 2 to the value 1, which is false. So we'll come here out of the while block, and we are assigning here to temp edge. All the block void of 2 is deleted. So our desirable or our head block should be the 2. And now we are assigning 8 to 2. Uh, or the block whose value is 2, and we are using next. And if next is not null, is the next is not null, so what we are doing is we are comparing temp next value, which is the value of 3, as we have already compared 2. Now we are comparing 3. If 3 is equals to the given value, which is 1, is it is not correct. So we are assigning to delete to next temp next, and temp next should move to block, as this block will be deleted. So we are moving to block ahead, which is sorry, uh, we are moving to block ahead, which is null. uh, okay, so and the node to be deleted, which is 1, is deleted, and the current iteration will be skipped, and continue will come here as temp next is clearly null, as this is null, so we'll return it. I hope it works, but it might not work as well. Error of undeclared null. Okay, sorry, my bad. Let's hope there are no further mistakes. The video is already 1 hour long. Yeah, it worked. Let's hope it worked for all. Yes, yeah, uh, yeah, it worked for 100%. Oh, thank God it worked. Okay, that's it for today. My head is hurting is there was so many condition in whatnot. The problem could have also be solved using recursion, but I thought recursion was a bit unnecessary. As you can see, the we solved the problem using 100% runtime, but the time complexity was bad. I can say, yeah, the time complexity, what it is saying, big of answer one, yeah. We are using this to delete. The time complexity actually shouldn't be so bad as you can see we are only using two memory block. One is for storing the pointer of to delete and one is for storing temp as head is already given to us, value is also given to us, and we are not doing anything that much. But I think we are using so many conditions, so in order to execute this, a lot of stack, not stack, I think if block is being used. But runtime is 100%. That's fine. That's it for today. Thank you for watching. Tomorrow, I will come after learning, uh, after learning double pointer and as table for sure. Yeah, that's it for today. If you like the video, like, share, and subscribe.